Okay, so in today's session, I'm trying to explain linear functions quite related to system of equations. Actually, we used uh, lines to determine number of solutions. So let's try this problem. Mm, Now here we have a line. This is the equation of the line, and let me roughly draw that line. Don't need to draw the exact line, right? Just a line, right? This line, that is the equation of this line. So let me name this line as line L. So 2x plus 3y equals to 5. Now we are talking about a different line which is parallel to this, right? And passes through 8 comma 5, that point. Right? So you can draw infinite number of parallel lines, but you can draw only one line through that point. So we are talking about that line. These two lines parallel, right? So this point, let me name this point as Q, 8 comma 5. So what do we need? We need the equation of this purple line. Let me name that line as line N. Basically, we need that equation of line N. Yeah. So to compute equation of a line, either we need 2 points on that line or 1 point and the slope. Here we can compute the slope of line N. Why? Because these two lines parallel. Right? So therefore we can use that idea. So first of all, I'm going to compute slope of line L. For that we need this form. Slope intercept form, mx plus b, y equals mx plus b. To get that form, I'm going to move 2x to the other side. Then that is minus 2x, because this is plus 2x. As I move that to the other side, it will change the sign. Then divide both sides by 3. Divide separately to create that form. Now, so we found the slope of line L, because we can compare these two. M equals to minus 2 over 3. Let's say ML, slope of line L. But line N is parallel to line N. Therefore, it's very obvious, both of these lines creates same angle with the x-axis. Right? You can easily understand that. If not, you can use corresponding angles, but I'm not going to explain that here because that's not the point. Right? So basically, these two angles equal, and more importantly, slopes equal, because the same rise over run. Right? So therefore, the slope of line N and slope of line L both equal. So Mn equals to Ml. Mn equals to minus 2 over 3. Now we have a better idea about that purple line. Previously we had 1 point. Now we have 1 point and the slope. Hence, that's enough to write the equation of this purple line. So maybe we can use the point slope form. We have 1 point and the slope. We can write y minus y1 m times x minus x1. So x1, y1, that's basically this point, x1, y1, and the slope equals to minus 2 over 3. So I can replace y minus 5 equal to minus 2 over 3, x minus 8. Then I think you can create that slope intercept form for this line. Y equals to minus 2 over 3x, y minus 1. Then multiply these two, 16 over 3. Then we can move this minus 5 to the other side. I think that's the required equation. Add these two, 15 plus 16, because 3 is the common denominator, 31 over 3. Right? There's another method. I'll explain that separately, but here we use the point slope form. Right? Now observe these two equations. Equation of this line, y equals minus 2 over 3x plus 5 over 3. This one, y equals minus 2 over 3x plus 31 over 3. So clearly, same slope, but the y-intercepts are different. That's the real idea. There's a difference, y-intercept. Right. Then this problem, whenever you have a problem like this, it's better, much suitable if you can draw a certain diagram, be a small one, to get an idea about the requirement. Sometimes we tend to compute unnecessary components, quantities. That's not the point. So we should be able to find the shortest path. In this case, to compute Q. Let's see. So line passes through the points. So clearly we have 2 points. Let's say K and L, 2 points, and is parallel to the equation. So this is a line actually. Right? Okay, so here basically we are talking about 2 lines. Can you understand that? So initially a line passes through the points, right? That's a one line. Then parallel to the equation, so that's another line, right? But one thing's for sure, that is these 2 lines parallel. Right? So we can use that idea. Initially this line, then a parallel line. Right? So let me name this line as line H. This line. Right? And we have 2 points on the other line. This one. That is line J. So we can mark those 2 points on line J, right, to get an idea about the situation. So let me mark those 2 points. 1, Q, 3, 8. So point K and point L. Right? And more importantly, these 2 lines parallel. But what's the meaning of that? How would you use that idea mathematically? Right? You should be able to express that mathematically through an equation. So what's the equation for this idea? So parallel means slopes of these 2 lines should be equal. So slope of line L, so line J, equals to slope of line H. So that's the idea. So Mj equals to Mh. Some people use the term gradient, doesn't really matter, same meaning. Now Mj and Mh, right? So that's what we know. Maybe we can use that to compute the value of Q, right? So line H, the equation of line H is 8y minus x equals to 16. Right now, to compute Q, what do we want actually? To compute an unknown, what do we need? We can't just compute that, right? We need an equation. To compute one unknown, we need an equation. To compute two unknowns, we need two equations. So therefore, in this case, we need one unknown, which is Q. To get that, we need an equation. You can't build an equation out of nowhere. We need a relationship. So here we have one. We just wrote that. This one here. So slopes equal. So we can use that idea. Hence, I am going to write slope of line J and slope of line H. To get slope of line H, we can use this equation. I'm going to create the slope intercept form. Move x to the other side, plus 16. Then divide the entire equation by 8, because my aim is creating y equals mx plus b. Divide separately. X over 8, that is 1 over 8x, plus 16 over 8, that's 2. Now, that's line H. Clearly, slope equals to 1 over 8, and the y-intercept equals to 2. So, therefore, MH equals to 1 over 8. Then focus on line J. You can't use this strategy to compute the slope of line J. Why is that? Because we don't have the equation of line J. So hence we use a very different strategy, which is rise over run, because we have 2 points, right? So Mj equals to delta y over delta x, or rise over run, like this. So the difference of y, y2 minus y1 over x2 minus x1. So compute that. So this is y2, y1, x1, x2. You can change the order. You can select K point as your second point and L point as your first point. That's not a problem. Mj 8 minus Q over 3 minus 1. Now we found Mj here. Maybe simplify a bit. Now, so we did start with this formula, this equation, sorry, this equation. So now we can use that here. So Mj and Mh, these two values should be equal. Hence, we can form an equation. 8 minus Q over 2 equals to 1 over 8. Now we want to compute Q. I think we can easily do that. So I think more importantly, instead of solving this problem, the most important part is identifying this thought process, right? Building equations, right? Whenever you have parallel lines, you can use this idea. For perpendicular lines, there's another relationship. So those words are quite important, parallel, perpendicular. Then we can solve this one for Q. You can use any method that you prefer. I would like to multiply both sides by 8, or you can use cross multiplication. Okay, let me use cross multiplication. Like this, 8 times 8 minus Q equals to 1 times 2. Or here we can multiply both sides by 8. Because I don't want to work with these denominators. But I can't multiply by 2 because that way won't be able to simplify properly. We need the bigger number. Like this. So 4, but we multiply that 8 minus Q entire thing by 4. So 32 minus 4Q equals to 1. And if you follow this method, 64 minus 8Q equals to 2. So 8Q equals to, after this, you can move 8Q to other side and 2 to this side. 64 minus 2. So 8Q equals to 62. Divide both sides by 8. That's your answer. From using this method also, move 4Q to other side and 1 to this side. So 31 over 4. Because 4Q equals to 31. So Q equals to 31 over 4. This way also you will get the same answer. Simplification is not difficult, but the idea very important, right? Yeah. 8 minus Q over 3 minus 1. Yeah. Now that's the x coordinate, sorry, y coordinate of point K. Right. I think maybe you can use, actually you can use the perpendicular nature to compute capital L. I can see a lot of similar parts between this question and the above one, but clearly there is a difference, that is this part, the perpendicular, right? So that's the key to build an equation, because we need an equation to compute L. For that, you can use this word. So perpendicular lines and parallel lines. We discussed about parallel lines. So let's suppose the slope of this line equals to M1 and slope of the perpendicular, the next line, M2. Since these two lines perpendicular, product of slopes M1 times M2 equals to minus 1. So you can use that. And also sometimes you can subject M1 or M2 by dividing both sides by M2. Then M2 and M2 can cancel. So M1 equals to minus 1 over M2. So you can use that relationship as well. The same thing actually, this one and this one, same thing. You can use either. Because whenever you have the slope of a line, you can compute the slope of the perpendicular line. That's the idea. So for example, let's say slope of this line equals to minus 1 over 4 minus 1 over 16. You can compute the slope of the perpendicular line, because that's basically the negative reciprocal of M1. right? Actually here, if you want to, you can build another equation. M2 equals to minus 1 over M1. That same thing, right? Negative reciprocal of the other slope. So hence this slope equals to minus 1 over M1. Then you can compute that, right? So that is, in this case, minus 1 over 16. So that's quite interesting, I think. That's a division symbol. So let me express like this: minus 1 division minus 1 over 16. Then change that division to multiplication by taking the reciprocal. 16 over minus 1. We can cancel minus 1 and minus 1. So we will get 16 as the slope of this line. So that word is quite important. Because of that word, we found the slope of that green line. So now let's move to our question. So you can use the same idea, actually, right? To compute. So let's express this situation through a diagram, right? Line passes through these 2 points, point A and point B, that line, and it's perpendicular to the equation. That's another line, right? Let me draw that line, this one. Don't think about that one as an equation. So equation, that's a line, right? Linear equation. And also when we are solving system of equations, basically we are talking about lines, right? Intersection points of lines, right? Now, these two perpendicular, which means the angle between these two lines equals to 90. Right? From geometry, you can say, okay, this one also 90, 90, 90, right? So we have 2 points on the blue line, A and B. And the equation of the pink line. Right? So let me name this line as line 1. This is line 2. Right? So you can compute M1 and M2. Then we have a relationship. Since these two lines perpendicular, this is how we write that. Line 1 perpendicular to line 2. But that's not helpful because that's not an equation. So the corresponding equation is M1 times M2 equals to minus 1. Product of slopes. So slope of this line is M1. Slope of this one is M2. That's the idea. There are different variations. If you want to, you can express this idea like this or like this. But the same thing. Please use one form. This one's much better, I think. So you can use that. According to the question, actually, you can change your approach. Right. So the idea is simple. It's basically creating an equation using this relationship, right? So for that, we need M1 and M2. So M1 is the slope of that blue line. So we can compute that very easily using rise over run. y2 minus y1 over x2 minus x1. So let me take this point as my second point, x2, y2, x1, y1. So subtract 1 minus, be careful here, this is minus 5 again. So 1 minus minus 5. So here, this is this minus sign. There's another minus sign here. Over x2 L minus 1. Right? We can simplify minus into minus plus. So 1 plus 5 over L minus 1. 6 over L minus 1. That is M1. To compute M2, you can't use that strategy because we don't have points. So we can use the equation. Create point slope form. Right? Sorry, create slope intercept form. Move x to the other side. That is 1x plus 8. Then divide both sides by 2. Y equals to, divide separately, half x plus 4. 8 over 2 equals to 4. Right? Please ask if you have doubts about those concepts, right? Those simplifications. So this is basically line 2, the second line. So the slope, can get the slope by comparing with x plus c. So m2 equals to half. If these two lines parallel, then these two slopes should be equal. But that's not the case. Now we have perpendicular. Hence, what's the relationship? This is the relationship. So m1 times m2 equals to minus 1. Now that's the equation. I said we need one equation to compute L. So here's the equation. So basically m1 is 6 over L minus 1. We're putting a bracket for L minus 1 times half. We can solve this one for L minus 1. Whenever you have your variable in the denominator, for example, like this, 1 over x equals to 7 over 8, you can use cross multiplication like this. So 7x equals to 8 times 1. Here also we can use that, but prior to that step, I would like to simplify 6 and 2. 1, 3. So now I can multiply 3 and 1, that is 3. L minus 1 times 1, that is just L minus 1. Again, don't forget to put the bracket. That's not a one term. Now this is the moment I can put 1 under minus 1 because I want to apply cross multiplication in this step. Let's do that. So minus 1 times L minus 1, 3 times 1. Then expand minus 1L, minus into minus plus 1 equals to 3. Then we can solve this. That's still just minus L, right? Minus L plus 1 equals to 3. We can move 1 to the other side. 3 minus 1. So minus L or minus 1L equals to 2. To get L, you can multiply both sides by minus 1 or divide both sides by minus 1. Same thing. So L equals to minus 2. That's the x coordinate of point A, minus 2. Right? So sometimes I think you can try the same problem whenever these two lines parallel, right? Then M1 and M2 should equal. So try that, right? I think you can understand that situation, right? Whenever we have two parallel lines, let's suppose that pink line parallel to the blue line, then M1 equals to M2, different question, right? I'm not talking about this one, right? So then you can solve that one for L, right? So I think it's a great step actually. As you change your L value, you can get different lines. That's the idea. Okay, I think that's enough for today's session. I'll explain a few more questions in the next one. Thank you very much.